Welcome to day 6 of calculus. Let's graph some rational functions. Please remember that you should always look to factor rational functions first before you do anything else. What's nice is on this first one, everything's nicely factored already. Excellent. The domain, as you will remember, is the set of all numbers that you're allowed to plug in. So think of all the numbers that you can't. And in this case, you can't plug in x equals 3 because that would make the denominator 0. So in this case, the domain is x such that x does not equal 3. Are there any holes? Are there any holes? Well, that would happen if we canceled any terms. If there was something on top and bottom that we canceled. There are no holes because nothing canceled. What about asymptotes? Well, vertical asymptotes occur where in the simplified form you have numbers you can't plug in, and we can't plug in 3. So there will be a vertical asymptote at x equals 3. But then you need to look at, and really kind of you should do end behaviors first to find horizontal asymptotes. But here's a shortcut. If the degree of the top is less than the degree of the bottom, so the degree down here, the degree of the denominator is 1. The power of x is 1. Now there is no x up there, which really just means it's x to the 0. If the degree on the bottom, the denominator is greater than the degree on top, then the vertical asymptote is always going to be y equals 0. And that's because when you do the end behaviors, the limit as x goes to infinity of 5 over x minus 3, as x gets huge, this gets huge. 5 over something huge is going to be 0. And then the other end behavior, x goes to negative infinity of 5 over x minus 3. As x goes to negative infinity, you have a really big negative number. It's still going to 0. The key difference is that when you're going to positive infinity, this will stay positive. And when you're going to negative infinity, this thing will be negative, so approach from below. What about the X-Intercept? The X-Intercept is going to be when y is 0. Is it possible for 5 over x minus 3 to equal 0? Is that possible? No, it's not. So there are none. You can also get a hint because the horizontal asymptote is y equals 0. You're never going to touch y equals 0. The Y-Intercept is when x is 0, so you plug in 0 into this, and you end up with 5 over negative 3. Remember, state your answer as a point, so the Y-Intercept is 0, 5 over negative 3. Let's put this all together. So we have a horizontal asymptote, we'll use, green here, x equals 3. So x equals 3 is right here. And let's use red for our y equals 0. So we know that here is a horizontal asymptote. Are there any x-intercepts? No, but there is a y-intercept at negative 5 over 3, which is like negative 1 2/3. So that's going to be, at that point, right, 1 2/3 is like right about, let's say, here. So then the question is, how do we go about placing the function? Well, we know by the end behaviors here that as x goes to infinity, it approaches 0 from the top, and as x goes to negative infinity, it approaches it from the bottom, which matches because it's got to go like this. It's got to touch that intercept. So if we're approaching from the top like this, we need to figure out the middle part here. And one thing I taught you before is that the degree of the denominator, if it's odd, one has to go up and one has to go down. So we know here's one piece of logic for you. You know that there are no x-intercepts. It does not cross this, so it can't go back up again from here because it would have to go up and cross, but it can't cross, so it has to go down. Because this number right here is odd, meaning the degree of the denominator is odd, the arrows have to go in opposite directions here. So if the left one goes down, this one goes up. And if you're ever confused about this, remember your bail, your safe operation is always going to be to plot points. Let's do another one. Adds in a slightly more dynamic numerator. Again, it's fully factored. Hooray! The domain is the set of all numbers that you can't plug into the denominator. So x such that x can't be, in this case, 2, because you can't plug. If you plug 2 in, you get 0 in the denominator. Nothing cancels, so there's no holes. But there's going to be a vertical asymptote at x equals 2, because you can't plug in 2 into the denominator in its simplified form. Now, what about horizontal asymptotes? Well, the degree is the same on the top and bottom. The degree on the numerator is 1. The degree on the denominator is 1. So it's really just going to be x over x. So the horizontal asymptote is y equals 1, because x over x is 1. What about the end behaviors? Going to infinity of x plus 2 over x minus 2. Well, we know it's going to go to 1, but the question is, does it go to negative infinity? Does it go from the top or the bottom? Well, when you plug in a big number, no matter where you plug it in, if it's positive, this is going to be bigger than this if it's a positive number for x. Like 10 plus 4 over 10 minus 2. It's going to get closer and closer to 1, but the top is always going to be bigger than the bottom, so it's going to approach from the top. But as you go to negative infinity, it flips. So you have negative, let's say it's negative 10. Negative 10 plus 4 over negative 10 minus 2 is negative 6 over negative 12, which is going to be 1/2. That's less than 1. It flips it over. The x-intercepts are when y is 0. So is there any way to make this 0? Well, that's when x is equal to negative 4. It's when x is equal to negative 4. So the point is negative 4, 0. The y-intercept is when x is 0, so that's just 0 plus 4 over 0 minus 2 is 4 over negative 2, which is negative 2. So the y-intercept is going to be 0, negative 2. And now we'll put it all together and make a graph. So first, let's put the asymptotes in. I like to do this. So x equals 2. So it's right here. And then we have y equals negative 1. Sorry, y equals 1. So that's right about here. It's halfway up, right there. So we have y equals 1. And then we have a y-intercept of 0, negative 2, which is right there. So that's 0, negative 2 is right there. Then we have an x-intercept at negative 4. So you kind of see what's going to happen here. You know that this has to be connected. And now the question is, does it go down here or does it go up? But let's look at the end behavior first. As it goes to negative infinity, it approaches 1 from below. So we know it's going to keep going like this. And as it approaches positive infinity, it's going to go like this. Now, one thing you can do is you can test, does it cross the horizontal asymptote? You can cross horizontal asymptotes. Is it possible for the horizontal asymptote, which is x plus 4 over x minus 2, to equal the horizontal asymptote, which is 1? Well, if that's true, then x plus 4 has to be x minus 2. But that just means that 4 equals negative 2, which is not true. So we've answered the question, can it cross the horizontal asymptote? No. So if you start here, it can't go up again. It has to keep going down because it can't cross the horizontal asymptote. And because the power in the denominator is 1, we know that if it goes down here, it has to go up right there. I'm going to jump to number 4 to jump difficulty a little bit. You can always go back and do number 3 if you want, but this one is not factored, so you need to factor it first. Factor out easy stuff first. You don't have to factor everything at once, and in this case you can factor out a 4 from the numerator and get x squared minus 3x plus 2, and you can factor out a 3 from the denominator and get x squared minus 4. Factor in pieces. This factors into 4 times x minus 2 times x minus 1, and this factors into 3 times x plus 2 times x minus 2. Before you cancel, you find the domain. What can't you plug into this, into that denominator? What could you plug in and make it 0? And that would be, you know that it's going to be the set of all numbers such that x can't be negative 2 because of this term or positive 2 because of that term. So there's the domain. Now you cancel, if you can cancel anything, but you can cancel that. So we know there's going to be a hole at 2 because that's the number you plugged in there to get 0. The question is, what is the y-coordinate? So when you simplify this, let's just write the simplified form, 4 times x minus 1 over 3 times x plus 2. You plug in 2 into this. If you plug in 2 into that, you end up with 4 times 2 minus 1 over 3 times 2 plus 2, which is 4 over 12, which is 1/3. So that 1/3 right here is the y-coordinate over here, so it's going to be 1/3. So that's our hole. Are there any vertical asymptotes? Well, what's left here in the denominator? Is there something we still can't plug in after we simplify? And that would be negative 2. So we now have a vertical asymptote at x equals negative 2. What about horizontal asymptote? Well, you should remember that if the power is the same for the leading term, so if the power of the numerator is equal to the power of the denominator, the horizontal asymptote is going to occur at just the ratio of the coefficients. So 4 over 3 because the x squareds cancel. So you have a horizontal asymptote, y equals 4/3. Let's talk about the end behaviors. The limit as x goes to infinity of y, and the limit as x goes to negative infinity of y. So you need to find the sidedness here. Is it coming from above or below? So let's look at the first one as x goes to infinity. So when you're doing that, you want to look at the rest here. When you look at the rest, the only thing that's really going to matter is this negative 12x, because that's going to be super big compared to just the 12 that's left, negative 12 down here. So if you take away something super big from the top, something relatively small on the bottom, you're making the numerator smaller, so therefore the whole thing gets bigger. Sorry, the numerator smaller, so the whole thing gets smaller. The denominator, you're subtracting 12, but you're subtracting a lot from the top, so the numerator got smaller. So in a fraction, if the numerator gets smaller, you're getting the whole thing smaller, so it's going to be below. And the opposite happens because the sign will flip, and when you plug in a negative infinity or something negative huge, it's going to add it on top, making this bigger. The x-intercept is when y is 0, and the y-intercept is when x is 0. So this is when y is 0, and this is when x is 0. So you can really just look at the simplified form here. How do you make that whole thing equal 0? Well, that's when x is equal to 1. When x is equal to 1, the whole thing is 0 because of which term? Because of this term. When you plug in 1, the whole fraction becomes 0. What about the y-intercept? That's when x is 0. So you're plugging in 0 into 4 times 0 minus 1 over 3 times 0 plus 2. And that's going to be 4 over 6. So our y-intercept is 0, 2/3, which is the simplified form of, it's negative, sorry, negative 2/3, which is the simplified form of negative 4/6. So let's put this all together. I like plotting vertical asymptotes. So if x is equal to negative 2 is a vertical asymptote, so here. And then we have a horizontal asymptote at 4/3. It's like 1 1/3, so it's like right here. And then let's plot intercepts. What do we got here? The x-intercept is 1, 0 right there. The y-intercept is 0, negative 2/3, which is like right there. And then there's a hole. Where's the hole? 2, 1/3, which is like right there. Kind of see what's going on there? So we know these are connected like this. So then you can ask yourself the question, does it cross the horizontal asymptote? You can think about that, and you can do that 2 ways. You can either set this equal to 4/3, or you can look at what happens as the function goes to negative 2. What happens as you go to negative 2 from the right? Let's look at that for a second. So we're doing the limit as you go to as x, make that a little clearer, as x goes to negative 2 from the right of 4 over x, this, which is the simplified form of what we're working on. So what happens as we go to negative 2 from the right? Well, you can think of it as when you plug in something about negative 2 into here, you end up with about 4 times negative 2 minus 1. That's the numerator is going to be about what? It's going to be about, make it squiggly, negative 12. The denominator, what's a little bit to the right of negative 2? It's going to be like negative 1.9. If you plug in negative 1.9 into this, negative 1.9 plus 2 is about 0.1. So 3 times 0.1 is over about 0.3. So it's a negative number over something small positive. So it's going to be negative something big. Because you can make this smaller by making this number closer to negative 2 from the right. It'll just make that smaller, which makes this smaller, which makes this bigger. So it's going to be negative infinity. And it kind of makes sense because it's already tilted that way. So if that goes that way, we look at our end behavior. We know as it goes to infinity right here, you're approaching 4/3 from below. So it continues like that. And then on the other side, we already know it approaches 4/3 from above. And we know that the power here, what's the power again? What's the power of this? The power is 1. So if it goes down here, it has to go up there. So it already went down there, so it has to go up on the other side. So right here. So I'm going to jump to solving a rational equation. And this one looks decently nasty, but remember, always factor first. So if we factor these, what do we end up with for a statement? We end up with r times r minus 2 right there. So then here we have r times r plus 2. And then here we have r plus 2 times r minus 2 because it's the difference of squares. We're trying to figure out what do we multiply by to get rid of all those denominators. What do we multiply by to get rid of all those denominators? Well, we need each piece of the term. So first, we know we need to multiply by r, because that's here and here. We know we have to multiply by r plus 2, because that's here and here and here, leaving us with just r minus 2. And it looks terrible in a way, but a lot of stuff will cancel. What happens when we multiply this out? Well, let's write out the whole thing. So all I've done is I've multiplied in this into all three of them. So we do that because we want to cancel a lot. So this cancels, that cancels, that cancels, that cancels, r plus 2, r minus 2. So what are you left with? Lots of stuff cancels, and you have nice denominators of 1. So now you just need to multiply each of those out and simplify a little bit. So I'll do one of these and then jump, but you get r squared plus 2r plus 3r plus 6, and then end up like this. You see the parentheses I put there? So when you multiply this out, you get that. When you multiply this out, you get that, but you see how I put parentheses around the whole thing? That's super important, and then this turns into this. Terms combine. I combined these two and those two. And now let's just write it out. So in this case, I distributed this negative sign. So what cancels here? Well, we know that the r squareds, these are going to cancel. And then you have 5r and negative 2r is going to form 3r. And then you have 6 and 8, which is 14. And on the right-hand side, you still have the same thing. It's a quadratic, so you need everything on one side. So we'll subtract 3r and we'll subtract 14. So it's going to be minus 3r minus 24. And then, oh, caught a little mistake here. You might have seen it already. That r gets multiplied in both places. So that's a 10r, r, r, r. Yes. So that's an r like that. So now when you subtract, you end up with 0 equals r squared minus 13r, because you're subtracting 3r, minus 14. Much better. And now that's a quadratic. You want to check to see if it's factorable or nicely factorable, and it is. It's r minus 14 times r plus 1. So r is equal to 14 or negative 1. You should check your answer by plugging those into the original to see if this side equals that side when you plug in your solutions. Let's do polynomial long division, which you have to do because the power here is greater than 1. The key phrase, remember, is leading over leading, and in this case it's x to the 4th over x squared. So x to the 4th over x squared equals x squared. So that ends up getting put right up here above the x squared term. And now you multiply. You take this and you multiply it in. X to the 4th minus 3x squared. Key is you subtract by putting parentheses around. And you get 0. And then this drops down, negative 2x cubed. And then remember, it's negative 18x squared minus negative 3. So it's adding it. So it's going to be plus 15x squared. You can drop these down too. The new leading is this negative 2x cubed. So you end up with negative 2x cubed over x squared is negative 2x. Goes up there, and now you use this one instead to multiply, and you end up with negative 2x cubed plus 6x. So when you subtract now, you end up with 15, sorry, this is not positive 15, this is negative 15x squared. Negative 15x squared, this cancels, plus 45. What's your new leading term? Negative 15x squared, and it's still x squared from here. So that's negative 15 minus 15. You get negative 15x squared plus 45. When you subtract, you get 0. 0 is what you should get if you do indeed have a factor. So to factor this completely, we now know that this is equal to x squared minus 3 times our new quotient, x squared minus 2x minus 15. But are we done yet? Well, this is a quadratic right here that can be factored, so we're not factored completely. So you have x squared minus 3. This is going to be x minus 5 times x plus 3. We are now factored completely right there. So we did polynomial long division to find this term, and then we did regular factoring to factor out the rest. There's a quicker method if the factor is linear. So it's linear because the power is 1 here. And the way you start it is, what number makes that 0? 3 makes that 0. and then you make this. These are the coefficients from here. 1, -5, 1, 25, -30. So the first thing you do is you drop down the first term, and now you keep on repeatedly multiplying by 3. Times 3 is 3, add them, -2. Times 3 is -6, add them is -5. Times 3 is -15, add them is 10. Times 3 is 30, add them is 0. So what this tells us is when we plug in 3 into this, you get 0. And the nice thing about that is we now have these coefficients of what's remaining. So we know that this is a factor, but the other factor is going to be, you know, that this is the constant, the x squared, and the x cubed. So it's 1x cubed minus 2x squared minus 5x plus 10. And now you want to say, okay, can we factor this cubic? The only thing you need to test at this point for cubics is by grouping. Is there anything you can pull out of the first two? Well, you can pull out an x squared and you end up with x minus 2. You can pull out a -5 and you get x minus 2. So you have x minus 2 in both cases, so you can factor that out. X minus 3 times x minus 2, and what are you left with? X squared minus 5. So that green ended up there, and then the yellow ended up there. So you got to take these to their conclusion. Now there are many more questions in this review packet. You are welcome and encouraged to do them.